Well, good morning and good afternoon, ladies and gentlemen, and thank you so very much for taking time out of your busy day to join us on our Condition for Success, How Ground Conditioning Can Boost Your EPB Advanced Rates. My name is Jeff, and I'll be in the background answering any general or technical questions that will come in through the Q&A with any technical issues. But we have a very large audience here today, and we're very thankful that you chose to join us. We have a number of things going on in our event today. We have a number of polling questions, so right now we're just going to go ahead and have you start with this first polling question. And we're just curious where you're located today. And as you're doing this, we'll go ahead and let you know that this event is being recorded in its entirety, and we'll be able to share with you at a later time the recording of this session. Also during today's session, we're going to be playing a number of videos, and they will appear on the screen to the left. And then as we're doing this here, I'm going to go ahead and take it over to the next slide and introduce the call to Craig. So Craig, I'd like to go ahead and turn the call over to you, and I'll share those results where everybody is located in just about 45 seconds.
Great. Thank you, Jeff. My name is Craig Allen. I'm from the Robbins company. I'm the marketing manager. We're very excited about this webinar that we have going today, and we, like Jeff said, we thank you for your time and look forward to your input throughout the seminar. Today's webinar is going to cover obviously the introduction that I'm doing now, the importance of ground conditioning, which Desiree Willis will speak to. I'll introduce in a moment. Then Jamie Ibarra from BASF will be talking about the importance of planning and products that are available from BASF. Richard Shulkins will be speaking from MAPI regarding treatment methods and products available from his company as well. And then the last formal presenter will be Brad Grothin from the Robbins company talking about EPB machine design for proper ground conditioning. So with that, I'd like to get started right away by introducing Desiree Willis. Desiree's been with the Robbins company for almost 8 years now. She does research and a lot of writing. She's traveled the world visiting various tunneling projects. The latest research that she's done covered 25 projects, 10 countries, using 40 different EPBMs. And the research that she and Joe Roby pulled from that white paper that they were writing is really what led to this webinar. So without further ado, I'll introduce Desiree. Desiree, take it away.
Thanks, Craig, for that introduction. We're going to go over a little bit about a study that we worked on. Over the years, we've found that labor costs for tunnels have typically been 30 to 50% or more. And this is true whether it's a soft ground project or a hard rock project. With such high costs, we are constantly looking at ways to reduce the time for tunnel construction without increasing staffing, which could result in substantial cost savings on the project. So we asked ourselves the question, what commonalities are present in EPB projects with fast advance rates? And in particular, we wanted to look at mixed ground projects because this is becoming a higher percentage of our EPB projects. And by mixed ground, we mean a mixture of materials that are easy for EPBs to excavate, such as soils, clays, and sands, and a mixture of materials that are not so easy to excavate. That might be consolidated hard rock, large boulders that can't be broken up with disc cutters, and coarser sands and gravels. So we looked at about 46 EPB projects. There's from all over the world, all TBM manufacturers, and we were looking specifically at average weekly advance rates based on 2 12-hour shifts, 7 days a week. These advance rates were given to us by contractors on the condition that we kept the names of the projects anonymous, so it is numbers and specs only. We looked at a few different factors. There was ground type, tunnel length, water pressure, type of drive motor, so that might be VFD or hydraulic, ground conditioning, the type of muck removal, that could be continuous conveyor, muck cars, the cutting tools installed in the cutter head, the location of the project, and the experience the contractor had with EPBs. This just had a breakthrough picture on it, but our results were wide-ranging. Our maximum advance rate was 184.8 meters a week. Our minimum was 33.7 meters a week. When we averaged all the projects together, it was about 85.5 meters a week. You can see it runs the gamut. And when we looked at what correlated with advance rates, most of the variables were not correlated at all. Contractor experience and the type of mucking system were lightly correlated, but there was a very strong correlation between ground conditioning and fast advance rates. And with that, we'll come to our second poll question over here. In your opinion, what is the most important factor in determining EPB advance rates? You can answer A, machine design, B, contractor experience, C, ground conditioning, D, muck removal method, or E, geology and water pressure.
And we'll leave this open. Go ahead.
Oh, sorry, Jeff. While we're waiting for the poll question to be answered, we've had a question come in. Desiree, somebody has asked, are there more materials that I can read or presentations I can watch on these topics?
Yes, definitely. We'll send out an email after this webinar that will detail a few different additional materials you can look at. In particular, we have a paper on this study that will be at the North American Tunneling Conference next week in Los Angeles. It's June 22nd to 25th. Our presentation's on Tuesday in the 1:30 session, so it should be around 4 o'clock. And the paper will be in the proceedings as well, so that's a good resource. And okay,
you should see the results.
Yes, it looks like a lot of people think ground conditioning, a lot of people think geology. I agree with both. I think that just kind of affirms our results. Geology and ground conditioning really go hand in hand. So now we'll talk a little bit about ground conditioning in general and just introduce the topic before we go more in depth. Based on our study, based on what we have observed, ground conditioning is equally as important as machine design for the logistical aspects on any EPB project. Using ground conditioning can not only improve the muck flow through the cutter head, it's also been shown to reduce wear on the machine, increase advance rates. The type of additive that's used, whether or not it's needed, in what concentrations are governed by international guidelines. And I believe Jamie and Richard will be going into that more in depth later. Some of the imperative things that are needed for a program are an accurate geotechnical baseline report. This is a report that details the hydrological and geological aspects of the project. In addition, laboratory testing is absolutely necessary to determine the proper ground conditioning regime. Almost all projects have various different types of ground, and you need a sample of each to determine which type of additive works best. And then finally, contractors, ground conditioning suppliers, and machine manufacturers need to work together very early on in the process to make the program work correctly. And this means even before the TVM is built so that the machine can be designed to provide that proper ground conditioning program. And here we're going to play a video. This is from one of our projects in Mexico. It is actually Emisor Oriente wastewater tunnel. And it will show a before video before we added additives. And it's so you can see how liquidized the muck is and how difficult it was to get through. Okay. And now we're going to show an after video after we added the ground conditioning agent. And this really helps to consolidate the muck, make it easier to remove. you can see the toothpaste-like consistency, and that is really what is desired in ground conditioning. It just makes it easier to transfer the muck. We'll play it one more time. Okay, and so that is just an introduction on ground conditioning. With that, I'll turn it back over to Craig to introduce Jamie.
Thanks, Desiree. Appreciate your input. The next speaker is Jamie Ibarra from BASF. Jamie's been in the industry for over 30 years and has had a wide variety of experience. As we know that experience can lead to a lot of learning from both the good and the bad times. He's overseen all different aspects of TBM assembly and different aspects of TBM projects. He's currently the TBM Technical Manager for Americas with BASF. So, Jamie?
Hi, everyone. Thank you very much, Craig, for the introduction. Everybody, most of the people knows me already on the industry. I've been more than 30 years making tunnels today with BASF. What the topic we're going to be talking today is about how we follow the steps for soil conditioning. Desiree was mentioning first how the TBM manufacturers, they have to have the GBR precise to design the proper TBM for the kind of geology they're going to be dealing with in the project. So here we are. In our side, the first step is very important to have the GBR in our hand, the more precise and accurate possible according to the studies made by the geologist. We analyze this information very thorough, and we're looking into all the information, like you can see in this slide. We look into this information to evaluate what kind of soil or ground the TBM is going to be dealing with. Most of the time, we only see only portion of this geology profile because they are boreholes. The boreholes are made between a distance in between 100 meters, 500 meters, sometimes even a kilometer, so we don't know what is in the middle. The geology is so important to us because the TBM is going to be dealing with different type of ground at the same time. Sometimes we have a mixed phase, sometimes we have a unique type of ground, which is ideal because it's very homogeneous, but most of the time, as everybody knows, is we have different type of ground. The machine is dealing with soft ground on the top, hard rock on the bottom, and clay on the one side, and that we need to know that information in order to do the studies in our lab. So we analyze the GPR, what type of ground we have in. We do look into the information to see if the ground is sticky, is coarse, is ground, is rock, and then we prepare ourselves for what is the next step. So the next step is going to be a lab test. It's very important before the TBM is even launched. The TBM has been designed already by the TBM manufacturer according to the GBR, obviously, and then in our side, we do the same analysis to determine and recommend what type of soil conditioning they're going to need, or the contractor is going to need to prepare that ground for that type of TBM. So it's a reference point, it's always a starting point, and I would take it as a second step. First step, analyzing the GBR. Second step, we're going to see what the samples of the soil that is being provided to us is going to tell us, and then we can compare that later on with the GBR. So here we are. We have first, we do the whole test that the geologists do in the GBR. We do it with the sample that we get from the contractors. We do all kind of tests, like you can see in this slide, torque test, abrasion test, sliding test, ground size analysis, stickiness, and so on. Why are we doing this? we're doing this because, as everybody knows, in the industry we have it's a range of different kind of technologies for different type of geology. So if we're working in clay, we're going to use an anti-clay polymer. We're using sand with water. We're going to use another type of surfactant with the polymer or without it. So it all depends of this lab test, the application of the technology we want to recommend to the contractors. So what we do in this is to prepare the ground for easy transportation. So the EPB machines work in certain conditions. They have to, first of all, we need to fill up the chamber, guarantee that the chamber is full of material, it's not full of air, to guarantee the easy flow of the ground through the cutting head into the chamber, through the screw conveyor, belt conveyor, and then to the disposable pit. But even though we need to always think about how that material is going to be transported to the filling land or landfill places that is being assigned to the project. While we're analyzing the GBR and doing the lab test, we can do that. We can get the ground as it is from the project. We prepare this ground to make it ideal conditions to work in this EPB. What these ideal conditions are going to be, so it depends obviously on the operation of the TBM, on the design of the TBM, and also in the soil conditioners. As you can see in the pictures, this is a ground that is being given as a very coarse sand, very rubbling, very loose, and that we turn it in the lab into a paste that we believe that is going to be the best condition for the TBM. And here's another example of what we do in the lab. Is the material we test it as it is again before we apply any technology that it can be used in this type of ground. In this case, it's a very sticky material. Sticks everywhere. It's sticking this lab. It's going to stick in the cutting head. It's going to plug this cutting head, and then therefore it's going to slow down the production rates. We do another test is we call it a soaking test or abrasion test. When the ground is very tight, it closes around the TBM. The TBM is going to need an extra force to propel the TBM forward. I don't call it a friction force. This is a soaking as a vacuum. It's pulling the machine. Don't let it go because it's too tight around the machine. So we need to know again how to the ground is going to affect on the TBM or affect on the TBM to the production or the advance rate. So what we do, we analyze the GBR, we do lab tests, we apply the right technology to the right geology or to the geology given. So we do, we use what we believe is the right technology for that type of geology, preparing the ground to be successful for the TBM. So now my next slide is just to give you some examples of what is proper soil conditioning after it's been testing. I believe Richard Chalkins from MAPE is going to be talking about the applications in the job site, but these are going to be some samples that we can show to you today as a result of a very good analysis of the soil conditioning. In the left-hand side, this is a Ballard siphon in Washington. They have oversaturated sand. I believe it was 20% oversaturated. We turn it into the right side, ideal for transportation, TBM, finished successful the tunnel, and they were having a lot of problems in that project until we do the lab test and we come with the solution. This one is York Southeast Collector in Canada, in Pickering. The problem there was it was clay, but it was also a lot of abrasive material in the clay that it makes it very difficult to mine, very, very hard, and then therefore very abrasive into the rippers. So we come again with a different application of the technologies until reducing the friction, reducing the abrasion, and again, helping the TBM move forward. Mexico City, I did talk about this project already, but it was the clay that they were having, it was slowing the TBM to 35 millimeters a minute, which is, for a lot of people, is a good rate. For us, everything can be improved. We come with the right technology for the type of geology they were drilling. The machine turns from 35 to 93 millimeters a minute. Again, moving forward in the right speed. This was in Toronto. Again, very sticky clay, very hard clay. They used the right technology. The machine, as everybody knows, finished the turn successfully. At the end of the project, they were producing 52 rings per day in two machines, so 25 and 25 average, but an average rate of 25 rings per day. So now we come to a full question, number 3. Have you personally noticed improvement in EPB projects when ground condition is used? The answers are A, yes, B, no, C, not involved in EPB projects. So now I turn it to Craig, and thank you for your attention.
While we're waiting for the poll to be tallied, there's another question that's come in. What are some recent examples of machines that have done very well and gone fast that had good ground conditioning programs?
And I can take this one. Oh.
Yep.
Sorry.
Go ahead, Desiree. Go ahead. Yep. Go ahead.
I'll give an example, and then you can, Jamie. There's obviously a lot of examples. There's a good one at Central Subway in California. Those machines were using a mixture of anti-clay polymer and foam. They just broke through last week, and they were able to excavate 40 meters in 24 hours and over 500 meters in 1 month. They were also able to go under some live rail tracks of less than 4 meter overburden, and they were able to do that without any compensation grouting. So that was a great project there.
And it looks like we have our poll questions tallied, and 75% of the people have said that they've had noticed improvements in EPB projects when ground conditioning was involved. So it, again, reconfirms everything that we're speaking to today. Our next speaker is Richard Shulkins. We've had a little bit of technical difficulties, so bear with us if there's no picture for Richard. But Richard is currently with Mapai. He's had over 20 years of experience in the tunneling industry, working on tunnels throughout the UK, Pakistan, and Southeast Asia. When he's not perfecting his skiing in Dubai, he's currently part of the underground technology team for Mapai. Richard, we'll turn the microphone over to you.
Thanks, Craig. Yes, my skiing ability is not fantastic. Lucky for you guys, you don't actually get to see me, though you do get to see the dreadful photograph there. So, moving on. Well, thanks, Jamie, for your presentation, and here we go. Steps to address changing geology in mixed ground conditions. There's a little bit of repetition with what Jamie said, but I'll try and move it on to what happens later on in the production in the TBM. Obviously, before you start your project, you need your geological baseline report. You need to have, which is rarely happens, 1 meter of borehole log for every 1 meter of tunnel advance for you to have some confidence of the ground you're going through. From this pretty comprehensive geological profile, you can generate a geological profile. This should also include all the pertinent values such as the water table, the end values, tunnel alignment, etc. And for every distinct ground condition, you should have a few kilograms of samples for your testing, all your granulometric curves, Atterberg limits, moisture contents, permeability records, and in situ strength. Without that, before you start, you're really on a hiding to nothing. You're going to get into trouble. Just to give you an indication, these are just a few random soil samples from around the world given to us by the Polytechnic in Turin. and you get the impression or the clear idea that every kind of soil exists. There's no one soil that's the same, so you need to have a plan suited to your particular tunnel drive, otherwise you're not going to be able to go as well as you could. I'm sure the next slide you've seen before. Once you've got your granulometric curve, you can fit it into this logarithmic graph, and you can see pretty much what kind of ground conditioning you're looking for. Oh, wrong slide, sorry, my mistake. So, also, before you start, you've also got to consider the environmental requirements for every country. Not all foams work in saltwater conditions. Sometimes the groundwater is going to affect badly the salt. This is something you also need to consider because not all foams are the same. Not all polymers are the same, and they can be badly affected by the chemical in the ground condition or the ionicity of the soil itself. You also need to consider that the skips, conveyors, or you're pumping the soil, because it's not just about cutting the soil, it's also about getting the soil out of the tunnel. Face pressure required, obviously. TBM selected. I was a little surprised in the poll that you didn't think that was so important, but I think a lot of people would consider that that's critically important, especially the cutter face design. With a bad cutter face design, you're not going to go anywhere. Local history, you're going to have tunnels that have been through the same ground condition before. You're going to get a good indication from there. Quickly going through the testing you can do. Once you've got your soil samples, you can, if you're keen, you can make your own foam generator. Cost you a few $1,000s, but it's worth it because you get good foam. If you're not so keen, you can also get a good indication from just using a liquidizer or cocktail blender. Any proper man will have one of these in their household. When you're actually on the TBM, one of the best ways to check whether your ground conditioning is done correctly is just by using a simple slump cone. It's the same in many ways as considering concrete. You want to have your soil to have some slump. If it has no slump, then it's not going to move through the machine. So you don't want it to have too much. You don't want it to have too little. So you need to be looking around about 6 to 12 centimetre slump. Obviously, that can vary as well. But that's the general idea. If your soil's too sticky, you can find out in the beginning just by adding water. Quite often people add too much water and make the soil or the clay too sticky to start with. It's not always good to add water to clay because all you're doing is making a sticky problem. If the clay is wet already, then you can use a clay dispersant and that will help to disperse the clay. But if you've got a dry clay, adding water is just going to make bigger problems, and dispersants don't actually penetrate into a dry clay, so you need to be looking towards more a polymer that will excavate dry lumps that are encased in a polymer slurry. Also, one of the things that you should be looking at is tools they cost a lot of money, so you want to be looking towards reducing the abrasion on the cutter head. You want to also control the permeability of the soil. If you can't control the permeability of the soil, you're going to get a lot of problems with running silt sands through the TBM. You're not going to be able to control earth pressure very easily, so you really want to keep in your mind to keep the permeability of the soil as low as possible, using foams, sometimes foams and polymers, even bentonite. Here we have a couple of videos showing a case study or a job we worked on in Bangkok. If you don't mind to play the video on the right. Okay, here we go. Yes. This is the before shot. This was when we arrived on the job site. I think it's quite clear that they were unable to control earth pressure. It was a bit of a mess. Fortunately, when you have a huge range of products and you can check the soil and the ground conditions, then you can In this case, we added a polymer, and we were able to, within I'd say 30 minutes, change the conditions from what you've just seen to the conditions you see here. You have to trust me, it is the same TBM, same ground conditions a little bit later on. It's just the fact that this one was taken on my iPhone and the first one was taken off the TBM camera. Splendid. So, anyway, what do you do? When you've started the tunnel, you've got all this information. After you've started the tunnel, you need to have your geological profile in the TBM cabin and notify the TBM crew of all the potential issues, specifically things like soil interfaces where you normally hit most of your problems. You have to have contingency plans in place. You need to have polymer, bentonite to absorb excessive water. You need to have your guys install the system rather than retroactively install it when it's too late and you're already in the trouble. And you need to have your crew trained and know what to do so they can change over from an existing system to a new system as quickly as possible with as little issues as possible. Common issues that cause problems. You always on a TBM have so many people wanting to change the ground conditioning parameters, but you really only need to have one guy doing it, one guy control, otherwise it's a disaster. Too many changes, too many problems, and you only really need to change the ground conditioning once a ring, maximum. The checks you need to do to find out whether you're going to get into trouble, you need to take at least once a ring, you need to take samples, you need to check the colour. It might not sound very important, but if you see colour changes, you can probably see that there are soil changes coming ahead. You can get colour charts from a guy called Munsell. You can get on the internet. Granulometry, you can get it in your hand. You can see whether you've got more silt, sand, clays, get a feel for the stickiness, abrasivity and permeability so you can anticipate changes before they happen. You also need to record the advanced speed, cut ahead torque, screw torque, thrust, force as an absolute minimum. And even from these figures, you can see when things are going askew, shall we say. Slump changes. If you find slump changes, alter the foam injection ratio a little bit to compensate. You also need to constantly check for excessive air in the top of the chamber. It's something a lot of people don't do. You get a big air bubble in the top of the TBM. You find that the torque goes higher and the thrust force goes higher, and you really need to keep a good eye on that one. Regular maintenance checks on all of the ground conditioning flow lines. Don't always believe the computer because it's not always telling you what's actually happening or what's being injected into the front of the TBM. So, thanks for that. The poll question number 4 is, when you have a question on ground conditioning, what do you typically rely on for answers? A, do you go to the international guidelines such as those from EFNARC and the Japanese Society of Civil Engineers? Okay. B, do you take knowledge from equipment suppliers and or ground conditioning suppliers? C, do you take information from handbooks or website references? D, do you take other contractors' experiences? Or E, do you always rely, sorry, I'm paraphrasing, do you use your own experiences, colleagues' experiences? Thanks for that, and after that then please hand over to Brad. Do apologise. Again, thanks for that.
Actually, while we're waiting for the tolls to be, the poll questions to be tallied, there's another question that's come in. It looks like it's directed definitely at the expertise of both Jamie and yourself, Richard. If you could narrow it down to 3 main points, what makes for good ground conditioning plan?
Well,
do you want to go first, Jamie?
Yeah, sure. Mine is quickly.
Okay.
For me, it's to narrow down a good plan of soil conditioning is you have to have a very good GBR, a very precise GBR, so a lot of information about stickiness or rubbling. Very good GBR. The second step, or the second point, it will be lab test prior launching of the TVM. And the third step, it will be starting the TVM with a reference point already given by the chemical supplier that you choose to drive the TVM with. Go ahead, Richard.
Yeah, okay, thanks, Jamie. The only things that I'd add to, obviously I agree with what you're saying, is that you just have to be prepared for the worst situation. You need to be fully prepared for the worst situation, and then when things start going pear-shaped, you can nip it in the bud quickly and get things back under control.
It looks like we have the poll question results in, and I'm not sure if we have some people that are trying to get in good with the speakers, but it looks like...
it's great, isn't it? Yeah.
It is. The knowledge from equipment suppliers and ground conditioning suppliers seems to be the highest response by far. So I think our speakers would say that that's a good answer. Our next presenter is Brad Grothin. He's had 16 years of experience in custom industrial and construction equipment design. He's currently the engineering manager for Robbins and has experience on a multitude of machines, but in particular with EPBM. So, Brad, we're looking forward to hearing what you have to say.
Thank you very much, Craig. This section of the presentation, I'm going to concentrate on the equipment associated with ground conditioning. Primarily, this is going to be the foam system, where we're going to spend most of the time. Going to start off at a system level and then come down to components and component features that we'd like to see. At the end, I'll touch on a couple of additional systems that we may want to have installed on the machine. Foam systems traditionally are supplied in two basic varieties. For the sake of this presentation, I'll refer to them as batch and continuous. First, I'll go over the batch system. I'll go over some features that you're going to see in both systems, really, and then go and look at some of the specifics to each one of those systems. So what we see here is a schematic. It looks like there's an awful lot going on. Really, we have an air prep over here, fluid. Both of those systems come together and are individually controlled at the foam generator. And from there, it goes forward to the base where it's applied to the soil. Looking a little bit closer, here's the foam generator. We have the air and foam coming together at the generator. It's not as fancy as Richard's blender. But what we're trying to do here is entrain the air inside the fluid, forming very, very small bubbles. As that goes forward and the pressure drops, those bubbles expand to what we see as foam. So both systems are going to have something very similar here. A couple of fine points that we want to see. We want to see some isolation valves so we can have maintenance on the foam generator. We also want to have a valve right after the foam generator. It's very difficult to test the foam all the way forward, and so we want to see how the system is responding and what the condition of the foam is as it comes out of the foam generator. The air side on both of them are going to be fairly similar. It's really the fluid side, which is down here, that the changes between the system are most noticeable. In this case, we have an agent tank and water supply. They come together in an agitated tank on the backup. We can get very good mixing here, and good distribution of that agent in the water to form the solution is what we want to see. Usually, this can be a pretty low ratio, so getting that distributed in the fluid is important. From here, the fluid is controlled through a series of independent pumps, progressive cavity pumps, or peristaltic pumps, so we have active control of the fluid flow. Some of the nice parts of this system is we have very good mixing, and then we have a lot of redundancy built into the system. So if we lose one single pump, we still have the majority of the pumps that are able to compensate for maintenance on that one pump. So we have a lot of built-in redundancy in the system. Moving to the continuous system, you can see the schematic is a little bit different, laid out different, but we still have our air prep and our fluid coming forward. But we'll also notice that there's a lot more valves, so we're trying to control the flow in this case of the fluid. Again, from the foam generators coming forward, there's very similar. We have pressure control, our valves for isolation, and for testing the foam. So the fluid system is where we see the change. In this case, we're trying to bring the water and foam agent together into a static mixer, and here it's continuously pumped forward. This has the advantage of taking up less room on the backup because we don't have that large tank, solution tank that we're pulling from. We're also able to change the concentration factor, at any point during that process should the need arise. A couple of items that we want to look for. Inherently, there isn't going to be the redundancy in this system. So while we could supply a single water pump or a single agent pump, we want to tie a couple of these together. So if we do have issues with one pump, we have some duplication in the system. Another couple of items that we can see here that can be applied to either system is the ability to add water to each line independently. So if for whatever reason we want to shut off foam going to a foam line at the cutter face, that's going to subject it to plugging. We'd have a plugging concern. So we can just pump water forward in that case to prevent clogging, or if we have dry soil and we just want to add water to that line, this gives us the option of doing that. We also have right here a polymer pump. As Jamie and Richard talked, there's a wide variety of chemicals and polymers that are available to us. A lot of these can be run through the foam generator, and so, if they aren't part of the foam package or the foaming agent, we can add them independently. A lot of stuff is going on. A lot of that control needs to come back to the operator. It's a critical part of the operation of the machine where we want to set all the different variables that we have associated with the system. It's also important that these chemicals are controlled with the advance of the machine. We set concentration factors, expansion ratios to a certain volume of soil. So if we double the advance rate of the machine, we're going to want those variables and the amount of chemicals that we're bringing forward to stay consistent with that volume of soil. So backing up a little bit, this really is a system. Each component is spread throughout the machine. The nozzles are at the face of the machine. It goes through a rotary union. The generators themselves we want located as far forward as possible. Once the foam is created, especially as it expands, it's very important that we try not to damage that foam as it goes forward. We don't want to separate the air from the fluid. That leads to the air bubble that Richard talked about a little bit earlier. The fluid pumps themselves we have a lot more flexibility. It can be here, it can be farther back on the backup. Really, we get some additional mixing in the lines if it's farther back. So those locations should be dictated really more through the logistics of the backup design than the pumping system. Going into the component level, what we see here is a section view of a foam nozzle. From the bottom, the foam comes through. These should be located really by area, cutting face area. We're trying to condition the volume of soil. So unlike a spray where you space it out radially, equal spacing radially, here we're trying to space it out according to the volume of material being pulled from the face. So we're going to see a lot more foam nozzles, or should see more foam nozzles as we move towards the periphery. We're also concerned about this earth pressure trying to get back into the foam line. It's going to cause clogging, and then it's a difficult thing to maintain. In order to help that, we want to have a check valve, which we can see here in blue. the design of this, we want to make sure it doesn't damage the foam, but it still prevents the soil from coming back into the machine. Moving to the rotary union, we're missing a little picture here, but it really ends up being a pretty impressive piece of equipment. Each line has to be independent moving forward. We want to make sure that we can control the flow to each line. If we try to tee the lines, we don't know where that flow is going for sure, and we will lose control of where we're distributing the product. We also have the chance of plugging one of those lines or partially plugging both of those lines if we tee them. The line size is important as we move forward. The smaller the line, the faster the volume we're going to damage the foam, especially in the rotary union. It's going to, because of the size of the equipment and the difficulty of getting that machining in there, making sure you have a good line size going through that piece of equipment is important. The pumps themselves should be of pretty high accuracy. We want to have good control and consistent control of those systems. They should be a positive displacement or volumetric, so a peristaltic pump, like I said, or progressive cavity pump are preferred. And we want to make sure that we don't oversize the systems in general or undersize. Most fluid components like to operate in a 40 to 80% range. That's where they're most accurate. If we get way below or way above that range, then we aren't going to have the accuracy that we want to see. So it's important that we don't oversize or undersize the system. They need to be appropriately sized for the advance rates that we expect and the soil conditionings that we want to see. So that's a quick overview of a foam system. There's additional systems that might be used for soil conditioning on the machine. Fine filler, we want to see a certain percentage of fines, usually 30% fines in the excavated soil. If they aren't natively in the soil, we're going to want to add them. This is primarily done with bentonite, though there are other options. This is a relatively simple system. What we can see here is how it is teed into the foam lines, which is an option. These can also be plumbed directly into the mixing chamber. This system can also be utilized to inject polymers, especially polymers that aren't able to run through the foam generator. Some foam polymers will plug up with the foam generator, so we want to inject them after the foam generator. And finally, it takes one push in many cases to see the effect when we apply all the foam and soil conditioning in space, where we get the best mixing. However, in the condition that we don't have a good control in the screw, Richard and Desiree showed a couple of videos where we had a lot of fluid just rushing out of the screw, so we didn't have good control. That requires us to inject material into the screw to gain control so the ground conditioning can take an effect. So we want to have porting right at the entrance of the screw. You can see that right here. This is an emergency system. It's preferable that we don't add chemicals there as standard practice, but it is something that we want to have in place should the need arise. With that, I'm to our final poll question. In your opinion, what has been the most important topic in today's webinar that you'd like to hear more about? Ground conditioning as it relates to EPB Advance Rates. B, planning and testing in order to develop an accurate ground conditioning program. C, ground conditioning for mixed ground conditions. And D, TBM design to optimize ground conditioning.
Thank you for the presentation, Brad. We're running a little bit tight on time. We get started a few minutes late due to some technical difficulties. But what I'd like to do now is, first of all, thank the four presenters, Desiree, Jamie, Richard, and Brad, for sharing their expertise. I know each of them could speak for hours longer on each one of the topics that they were talking, and they have a vast amount of expertise to draw upon. So what we'd like to do now is turn the program over to the audience. You'll notice on the right-hand side where you're seeing the poll questions that have just popped up, there's a tab there for question and answers. You're welcome to enter your questions in there. If for some reason we don't get to your question during this live webinar, we will respond to you afterwards. We'll make sure that we get an answer to your questions or at least address any issues that you bring up. So with that, I'd like to turn the program back over to Desiree to coordinate and facilitate the question and answer session.
Thanks, Craig. Yeah, I'll be moderating this question and answer session for the next 10 minutes or so. So we have one question. I think this is probably for Richard or Jamie. Are there any new types of foams or polymers you're working on that you could tell us more about?
You want to go ahead, Richard?
Yeah, sure. Okay. Yeah, there are quite a lot. There are so many different products that we have available to us. People tend to keep in their mind only foam and polymer, but there are so many different types of foam, there are so many different types of polymer, and also you've also got to consider that, especially when it relates to ground where you don't have fine content, there are a whole raft of filling materials that you can put in combination with foams and polymers. There are so many variables, it's very, very difficult for a contractor to get their head around them. I know because they're unaware of most of them, and I hope this webinar at least gives you some indication that there are a lot more things that you can actually try. Jamie?
Yep. Well, to answer that question from my point of view, yes, there's always room for improvement. Soil conditioning has been on the market since probably 90s. So always room for improvement means we always face problems on the projects regardless of the knowledge that we can provide into the industry or what we believe that we know. So to address the difference of soil conditionings and or soil conditions, we always improve and searching and do research and development of the product that we exist, or we develop a new product in order to deal more effectively into the geology that still today we have a problem with.
Okay, great. Another question that I think Brad, Richard, or Jamie could answer. Which international ground conditioning guidelines would you recommend using as a reference?
Well, do you want me to go first?
Yeah, sure. Go ahead, Richard.
Yeah, it's a tricky one, really, because my answer is I don't think any of them. If you want to know, you have to do yourself. There are some papers by a guy called Milligan. EFNARC doesn't really do what you want. It doesn't give you enough information to enable you to do a project. So I don't think there's anything actually available as a guideline or a specification that's suitable to help a new project at the moment.
Yeah. Yep. Thanks, Richard. My opinion, good planning for ground conditioning. Well, we already talked about all the planning or all the steps that we need to do in order to have a good soil conditioning. I agree with Richard what he says. There is no any 1, 2, 3, 4, and bingo, you have a successful tunnel. Always a tries and errors. Always what we provide as suppliers of the industry and soil conditioning is a reference point. We have a very small amount of material to be testing with. We don't have a TVM in our labs, so we need to basically we need to do the tries and error on the TVM. But we start with a good point with the technology that you might be using. That doesn't mean the last technology, but it means the technology you're using, which is going to help you to have an idea of the quantities and the right condition of the ground, as Richard shows in some videos in his presentation of how to change the condition of the ground towards what you need in your project in order to be successful and manage the ground that you're dealing with. Yep.
Okay, I think this next question is for Richard. Why does the air bubble in the chamber cause higher torque and thrust?
Yeah, it's a question I've been asked many times. Can I just say, because it does. I know it's a crap answer, but it's just a fact. When you have a big air bubble in the front of the TBM, on the crown of the TBM, you always get the corresponding rise in torque and thrust force. There are many theories about it, but I'm not going to expound my theories here, but just know it as a fact that it does. You need to get rid of that air bubble. So I could explain it, but not in the time that I have available. It's a tricky one to answer. Just know that the air bubble does do that, unless you're in hard rock where you need the air bubble, which is a different case altogether.
Okay, I think we have time for a couple more questions. This one might be for Brad, or anybody could answer it. What can contractors do to make sure their TBM is set up optimally for the necessary ground conditioning program?
Well, kind of like you asked for guidelines as far as soil conditioning, really the more information we have up front, the better off we are. So if we know what kind of conditioning we have to have, the better we know the soil, the better we can plan first the cutting head, address the soil, and then sizing of the foam systems, and really having a plan of what we want to have on the machine to address the ground that we have. So really it comes down to planning and knowing what we're going to excavate.
Okay, and this next question could be for any of you. Is there any way to sample and test unconditioned ground in front of an operating EPB?
I'll answer that.
I didn't get that.
Go ahead, Richard.
Sorry, I didn't hear the question.
Is there any way to sample and test unconditioned ground in front of an operating EPB?
No. Unless you take soil samples from boreholes.
I agree totally. You can't test the ground with the TBM. It will be too late. If you test your soil conditioning with an operating TBM wall, you can't create EPB without soil conditioning, first of all. Secondly, you're going to be having problems, big problems, because a large lab that you have in a TBM. So the answer is no. Agree 100%.
I will add that, so when the machine is operating, there's no way of doing it. You can certainly do probing operations, grab soil samples when the machine is stopped, but not when it's operating. So that you do have some ability to take samples ahead of the machine. Again, there's considerations that you need to be aware of, especially when you're underneath pressure, and how do you get those samples, but definitely not when the machine is operating.
You can take, I suppose you can take samples from probe holes, but it does seem excessive. Yeah. It's not something that most people would be prepared to do, but you can stop the machine and take core samples from probe holes.
Right. Yep.
Okay, and another question. Are there any guidelines or recommendations for cleaning and maintenance of the foam system?
Yes. In short, I mean, it's a mechanical system that needs to be maintained. That's usually supplied by the manufacturer. Some of the, systems that need to be looked at, especially are the generators. Those can get fouled over time. During cutter changes, you want to make sure, and there's some indication on pressures or system parameters. As Richard said, some of that's displayed to the operator, but it's something that you always want to look at with your own eyes as well. So the short answer is yes.
Okay, and I think we have time for one more question. What other factors besides ground conditioning are correlated with EPB advance rates? And I can answer a little bit of it, and then maybe Brad can answer. When we looked at our study, some of the other factors included the mucking system. We found that continuous conveyor use was actually lightly correlated with increased advance rates over muck cars and other methods. And then, of course, contractor experience, which I think makes sense. The more experienced contractor is going to know how to operate that EPB properly, whereas a new contractor is just learning how to operate an EPB. And those were the two main factors from the survey, but there might be some other factors in terms of the EPB design that Brad could speak to.
Well, I would say it's the suitability of that design. So the ability for the machine to excavate the soil that it's in. So mixed ground is going to be more difficult to excavate than a very homogeneous, uniform soil, a very nice clay, for instance. And so really it's getting the most out of your machine and systems in the ground that you're mining in. So that, there's a lot of things that are going to touch on that, especially your cutter head design, but then also, your planning, your ability to treat and condition the soils. I would say those are your primary, and ability of erecting your segment rings. For example, the skill of your crew on things that aren't even, related to the actual mining. So logistics on a machine, segment erection, these are all things that tie into advance rate, and they might be covered under the umbrella of the experience of your contractor.
Okay, great. And I think that's all the time we have for today. Thank you very much for attending our webinar. This is actually the first in a series of webinars, so you can look forward to hearing more from us. They're all free, and there'll be a variety of interesting topics. Thank you very much for participating. And again, if we didn't get to answer your question, we'll make sure to answer it after the webinar by email.
Thank you, everybody.